Okay, last week we have the quiz. I quickly take a look to what we have done before, and then I think most of you have written down something. Okay, don't worry too much. At least I think most of you actually have tried your best. And then for the final exam, I will also give you some, I think, some tips or some remarks, maybe in the next lecture. The next lecture is the final lecture, I think, okay? So after the end of the materials, talking about the last chapter next week, I will give you, or I will emphasize some important areas, okay? And then you may pay more attention to those important areas which should facilitate your revisions, okay? Now, I think you already know the style for the test, and then actually the examination will be similar, okay? I will ask you some questions, some short questions in the first part, and then in the next part actually will be some further questions, then some calculations, okay? I will mention about the final exam more maybe in the next lecture, okay? But the idea is that it will involve both some question and answer, and then will involve some calculations. And then in the final exam, you will also need to plot some graph, okay? Using the graph paper, I'll give you the graph paper, and then you need to plot some graph, okay? So, say for example, for the lab sections, I think we have mentioned about the way how to find the optimum bitumen level, okay? And then for those kind of things, you need to plot a graph and then to find the optimum bitumen level. For those kind of things, I think you need to know how to do, and then you can know the way how to plot the graph and then find the optimum bitumen content, okay? I think it is an important topic that you need to pay attention, okay? And then actually you also have the road design, actually you have learned about that, and then it must appear again in your final exam. And then also we will mention about the drainage design today, okay? How to design the drainage system for the highway. And then you also need to pay attention how to design for the highway drainage system. And then for the calculations of the compaction section, you also need to pay attention, okay? So I will mention more maybe next week. But the style, I think you already know for the highway engineering, okay? Now, if you take a look to the model, I've already put the assignment 2. And then you can take a look for that, and then suppose you should hand in by 29th of November, okay? So you still have 1 more week for that. And then I also put the lab sheet 2 on the model. For the lab sheet 2, actually, it is about the CBR test. I just open the file and you can take a look. Now, for the CBR test, actually, it is for the California bearing ratio test. I've already mentioned the way how to perform the test in the model. Also, in the class, we have mentioned about the way how to perform the test. As the equipment is out of order, so we will not perform the test, okay, in the face-to-face mode. But I have already put the result right here. We have 2 soil samples. One is number 1, the other one is number 2. So already for the penetration and for the load, I have already given to you, okay? So for your lab report, you can use this kind of results and then to find out the values. Of course, I have mentioned about the moisture content and then the dry density. Try to find that from the data that I given to you. And then try to evaluate the CBR. That means the Californian bearing ratio for both samples. And then for sure, you need to give me the objective procedures, test data. Actually, it's already stated in the lab sheet. In the lab report, actually, you just need to restate those kind of information, or you can give me some additional information based on your study. And then give me some discussion and then conclusion afterward, okay? So totally you have 2 lab reports. So the procedures and then the lab sheet I've already uploaded to the model, okay? This is for the lab. And then for the lab 1, actually it's about the Marshall design. I have already put the result here. It is actually the mass in the air, and the mass in the water, and then SSD in air. I've already put all the results, and then I put on Moodle. So you should be able to finish your lab report based on this data, okay? And then I think for some photo, actually I have, and then some of your group mates have already put it on the put it on the WhatsApp group. Then actually you can download those pictures and then put in your lab report. And then for others, like when you are heating your specimen and then, or you are compacting your specimen, you should have taken your own photo. If you still remember, we have used the Marshall test for your sample. You need to have compactions. And then I suppose you have your own photos already, right? So I haven't attached any compaction photos for you, okay? So you should have already some of the photos. Now for here, actually, as you can see, we have group 1 to group 7. And then for group 7, I have a remark for that. And then the result is too large for flow and can be discarded. So you may just use group 1 to group 6 data for your analysis and then for your design. You may ignore the group 7 data, or actually you may also put it there and then saying that because the result is too large and then it can be discarded, okay? Both can be done by yourself. I don't have any restriction whether you have present the result or you don't present the result, it doesn't matter. If you present it, then it's just saying that it is out of the range, and then we may not consider the result in our design. If you don't consider that, it is also acceptable, okay? Because it is out of the range, okay? So, any questions before I go on? One more thing is that about the lecture arrangement in the next semester. Now, maybe we will arrange 1 lectures in the evening as well. We will let you know because of the arrangement for the class. In order to invite the guests easily, so maybe we will arrange 1 of your subjects, like maybe project management, to be delivered in the evening. Okay, just 1 lecture. I mean, just 1 subject. 即係一科可能咧喺夜晚上都唔同。Okay. Okay. I mean, in the next semester, maybe there will be 1 module which will be delivered in the evening. I will let you know later. Okay. But just 1 module. Don't worry about that. Just 1 module because of the convenience to invite our guests. Okay. So there's 1 module, then maybe we will deliver in the evening. 即係有一科咧，我哋可能喺夜晚上啊，即係同各位講聲先。有一科咧，可能 我哋位夜晚上。There may be one module that we will deliver in the evening. Just I let you know first, OK？ 有一科我哋可能喺夜晚上同各位講聲。OK？ Now, then any questions before I go on? Any questions? Okay, next week I will give you some remarks on the important areas so that you can pay more attention before you go for the final examinations, okay? But as I mentioned, if you have any difficulty to a particular questions, don't leave it blank, okay? Just try to write down something based on your own understanding, okay? Because I try to give you marks if it is related, okay? If you leave it blank, then I can't give you anything, okay? Just write down what you have in your mind or impression, okay? Because actually you have joined the class, I think more or less you will have some idea for some of the items or topics. So don't leave it blank, okay? Just write down something. Because for this subject, I understand that actually it's quite a lot of materials. Many standards and then many criteria. Just write down something that in your mind, okay? Okay, so you have just the lab report left and then the one more assignment. Now, for the lab report, I suppose that you can hand me on or before 10th of December. That means at the study week, end of the study week, okay? I have already put down the submission date right there. I put it as the end of the, not end, it's the 10th of December, okay? So from now on, you still have at least 3 weeks of time, okay? So you should, well, start your lab report and then to discuss with your board member, okay? Okay, after talking about the, let me start the recording. Okay, after talking about all the road design, say for example, for the highway design, for the thickness of the bituminous layer, and then for the concrete layer, and then we have also mentioned about the foundation design, how to do the compaction, and then for the dry density. And then also we mentioned about the bituminous material, what kind of bituminous material to be put on the road surface. And we also mentioned about the horizontal curve and then the vertical curve design for our road. And now we reach to another important topic. We call it the drainage design. Because I think you know that there will be rainy day, and then there are actually the rainfall on the highway. And then the rainfall actually will cause the safety problems, because actually it will reduce the ski resistance of the road, and then it can cause accidents easily. And then also the flooding of the road will cause another problem. For the road users, actually when the overflow of the water, then it will cause inconvenience and sometimes dangerous situations to the road users. So that's why we need to drain our water away. And then actually it's a question how to put our drainage system on the road. Well, if you crossing the road, I think you can see some gully on the road actually. You know the Hancock boy, so actually those kind of gully is actually the way how they collected the water or collect the rainfall on the road. And then the problem or the question is, how can we arrange those kind of gully on the highway? What is the spacing of the gully? And then how to design for the cross-floor for the road so that we can collect our waters or rainfall immediately. So that's the questions. And then actually it has been studied by the Highway Department. And then they have already published a guideline, or we can call that guided notes, to let engineers know how to design for the drainage system. Okay. So today we will mention about those kind of questions and those kind of design system for the drainage on the highway. Okay. So actually, the lecture notes is largely based on the guidance notes on the drainage, on pavement drainage design, which is actually released in 2020. Okay. Actually, it is developed by the Research and Development Division of the Highway Department, and then we largely follow what they have said in the guidance notes. Well, actually, for the first revision, it is actually from the guidance notes 35, and then which was roll note 61. Firstly published in 1983, and that is actually based on the Transport Research Laboratory report number LR277. Well, the guideline right now we are using is actually based on the so-called the latest rainfall data, because actually you know that the rainfall is changing from time to time because of the climate change. So actually there is also the need of the change of the drainage guideline. So right now we are using the latest data and then to design for drainage. So for here you can see that this is the cross section of the road, and then basically we will have several components. As you can see here in the middle part of the road we have the carriageway. Carriageway is actually the area that our vehicle goes ahead and forth, and actually it is the length where our vehicles is riding on. And on the side of the road, basically we have a shoulder. Shoulder is actually a location where our vehicle can park right there for emergency system. And then on the other side of the road, actually is the footway. Actually, it's for the pedestrian. And then there is also a so-called drainage ditch. It is actually for collecting the the rainfall. Or you can see that on the footway on the other side, you can see that there is some gully right there. We call that this is the gully. This one is the gully. And then there are actually somewhere we will collect the rainfall. And then there's actually some pipe, and then the rainfall collected will be transferred to the manhole. And then from the manhole, it will transfer to the next one, and then finally they will be transmitted to the sea. So actually this is the cross section of the road. As you can see here, the one here actually we can call it as the gully. It is actually put on the side of the road. And actually you can see that in the middle, there's some manhole right here. Manhole is actually a central collector. You can see that the rainfall collected at the gully will be transmitted to the manhole. And then the manhole will collect the water and then transmit to the next one. And then the water actually will fall along the slope. It will collect and then fall along the slope. And then finally we will discharge it to the sea, because actually we need to release the water to the sea, okay? So actually there are two kinds of drainage system. One is for wastewater, one is for rainfall, okay? So the one that you can see on the road basically is for rainfall. If you can take a look from the advertisement from the government, actually they have already asked you not to put the wastewater in the gully because they are actually just for the rainfall, okay? And then for wastewater, actually there's another system to collect the wastewater. And then the wastewater have to be treated before they are discharged to the sea. Okay, they are so-called the wastewater treatment plant to collect the wastewater like the toilet flush from your home. And actually they are transmitted to the so-called the wastewater treatment plant. And then you have some physical and then biological treatment to remove those kind of chemicals, and then you can discharge it to the sea. But for the rainfall, basically we don't have any treatment, and then they will directly transmit to the sea. Okay, so don't put the so-called the wastewater to the gully on the road because they are mainly for the rainfall, but not for the wastewater. And then you can see that basically along the road there are different kind of gully right here. And then actually they are put in some spacing. So actually today we will mention about how to calculate the spacing of the gully so that you can collect your water on the road and to avoid from flooding of the road. So today we will mention about the rainfall intensity. There's what kind of rainfall that Hong Kong have. And then we will have the so-called serviceability state consideration. And then we will also have the climate consideration. And then just like the concrete design, we also have the ultimate limit state, or we can call the ultimate state consideration. And then we will mention about how to find the cross floor. Cross floor is actually the slope in the perpendicular side of the road, not along the road. Along the road is the gradient. The slope actually perpendicular to the main direction of the road, we call it the cross floor. And then we will have the gully spacing, how to design for the gully. Okay, so we'll mention one by one. Now, basically, when we are talking about some design, or we can call it the hydrologic events, like rainfall or flooding, or actually typhoon, you always heard about a word called return period. 幾多年一遇啊？10年一遇、100年一遇、1000年一遇 ，OK。You will also heard about this term. OK， 鄭州係啊，鄭州之前嗰場雨 OK。嗱 ，so you can always learn about what is return period. Now, return period actually is self-defined as the average period of time expected to elapse between occurrence of events at a certain site. In other words, a 10-year event actually is an event of such size that over a long period of time, say 10 years, between the events of equal or greater magnitude. That means it will happen like for every 10 years. So we can call that it is a 10-year event. It is actually just an average. I'm not saying that the 10-year event must happen for every 10 years, but just on average, the probability of having that is just not very high, but just 1 in 10 years. So actually, as I mentioned here, a 10-year event has a probability of 0.1. That means per year, that means the probability that it will happen per year is 10% or 0.1. For 100 years event actually in the same meaning, the probability having that is 0.01%. I mean 0.01 or just 1%. But it doesn't mean that it will happen exactly per 100 years, okay? It just means that the probability of happening is around, well, 10% or 1%, depends on the numbers of years of return period. So actually just mention about the likelihood of different rainfall system or rainstorm events. It is very difficult to say that whether we will have 100-year event next year or not, okay? We just mentioned it is just a comparison, whether this kind of rainfall will happen or not. So it is just the likelihood of the rainstorm event, okay? So it is not very likely to happen if you have a very large return period, okay? But I can't tell whether it will happen tomorrow or not, okay? So when we design, we will depend on the so-called the return period, and then we will design for a particular intensity of the rainfall, and then actually the probability of happening actually is not high. So actually it is good enough for us for our design purpose, okay? So basically for our drainage system, we will design for a rainfall intensity with a probability of 1 in 50 years occurrence, 即係50年一遇, to tally the design return period of carrier drains. Well, you may query, why not 1 in 100 years? Why not 1 in 1,000 years? Now actually, 1 in 50 years is actually good enough for our design when you are balancing your economy or investment system. Now you can think that if you design for 1 in 1,000 years, of course it will be very safe, but your society needs to invest a lot because you need to build a very strong drainage system, which is actually never or very seldom to happen, okay? And it is a kind of waste if you are designing too high standard, okay? After balancing your risk and then balancing your investment, and then it is think that 1 in 50 years occurrence is already good enough for your design. And as you can see, the rainfall intensity with the storm occurrence are as follows. So for the table 1A, you can see the maximum rainfall intensity and the flood width for the frequent storm event. Like for the first one is 2 per year. That means there will be 2 times of the rainfall around with the maximum intensity of 147 mm per hour. With this kind of intensity, it will happen 2 times per year. And then the flooded width will be in the normal road, it's around 0.75 meter. And then for the hard shoulder in the expressway, around 1 meter. Now what is flooded width? Now for here, I can draw down something just like your road. This is your road here on the both sides. And then this is your footway. And then when the water is here, then your water will be right here. And then here, this is the so-called flooded width. That means your water actually will be with a width, then it is full of water, okay? Then you can see that if the normal road, well, if it has a so-called 147 mm per hour, then the maximum flooded width that we allow is around 0.75 meter. And then for the hard shoulder in the expressway, we just allow it to have 1 meter for the flooded width. And then for 1 per year, then it is higher, and then the further width we may allow is 0.79 and then 1.04 meter for the expressway. And then for some the so-called the heavy storm event, like this is for the frequent storm event. That means it happens quite frequently. And then you can see that, well, 1 in 5 years and then 1 in 50 years, the further width, we don't want it to be too large. And then it is around 0.97 meter for the normal roll. And then for the hard shoulder roll, we just limit it to be 1.34 meter. This is the maximum rainfall intensity and then the further width for the heavy storm event. So actually, we will see these kind of tables later. For different area, we actually have different criteria. And then this is actually the locations in Hong Kong. You can see that different area, actually, they will have different rainfall. And then we will have different design for different area. Now you can see that the one with blank, there's no hash right here, then we can call the general applications. We will have a criteria for general application later. You will see that very soon. For the Tai Musan area, which is actually some locations right here, actually, if your design zone is within this location, then we can call that the Tai Musan area. And then for the Lantau area, you can see that this is the Lantau area. If you are in the airport or in the Lantau Island, part of the Lantau Island, then for here, actually, you will follow the one in the West Lantau area. And finally, if your location is within the North District area, just like here, just like you are in Fanlang or in Luowu, okay? Then you will be in this kind of area, then you will follow the so-called the North District area. Now I will mention about that very soon, so don't worry about that. And then for the all remaining area, actually will be the general applications. And then for our design, actually if you are designing for the expressway, the design further width on the expressway should remain within the hard shoulder. And then even for the so-called heavy rainstorm of a probability of 1 in 50 years. So actually even for the so-called heavy rainfall, very heavy rainfall in 1 in 50 years, we want to limit our design further width within the hard shoulder. And then for the normal roll, if the gullies are wide, now basically we want to limit our further width with width of 0.75 meter. And then this 0.75 meter actually belongs to the so-called rainfall of 147 mm per hour. Now for the 147 mm per hour, as you can see here, actually belongs to the case of 2 times per year. And then for here, actually, if it is exceeding 0.75, it is 1 times per year. So right here, we don't want our so-called further width to be larger than 0.75 meter. Now actually, the way why we want to limit it to 0.75 meter is that we don't want the water width or the further width to be too wide, so that the water goes into the driveway and then spreads the water to the footway. So that's why we want to limit our further width within 0.75 meter. And then this is for the normal road. And then basically when we consider the road design, we have 2 considerations as I mentioned before. One is called the serviceability state consideration. The other one is called the ultimate state consideration. Now the spacing of the road gully actually is to design so that the flow of water in a curve is limited to a maximum tolerable width. That means we don't want the width or the product width to be too wide. But however, as I mentioned, if you are designing too close gully, then your product width will not be wide, but it will be very expensive. Like stated in the guidance notes, it requires 2 to 5 times more gullies in order to reduce the product width by 50%. So if you want the product width to be very, very narrow, then actually you need to have 2 to 5 times more gullies in order to reduce half of the product width. So actually, as I mentioned, it is a compromise between the need and then the additional cost to be built on the drainage. So for the surfaceability state, actually we will just consider suitable product width. And then the principle actually is to limit the likelihood of the water flowing under the wheel palm of the vehicle, traveling at high speed, and then splashing over the footway while traveling at the low speed. But that means actually for the surfaceability consideration, why we need to limit the product width. Because we don't want the product width to be too wide, actually will goes into the driveway of the vehicle, so that the wheel will be wetted and then cause dangerous situation to the vehicle. And then you know for the vehicle, actually, if they drive slowly, they may also splash the water over the footway. And then all the pedestrians will get wet. Okay? We also don't want the splashing of the water on the footway. So we want to limit our product width to, say, 0.75 meter under the heavy rainfall conditions. So this is the consideration for the surfaceability state for the road, for the drainage design. Because actually for 0.75, it's just start to reach the wheel path of the vehicle. So we think that it is good enough for our design. And then for the normal road with actually moderate to steep gradients, we want a smaller flooded width actually. Now if your road is having a steeper guidance, actually there will be a large quantity of water flowing in the channel. And then if there's a so-called partial blockage of the inlet, we will actually result in considerable proportion of the flow bypassing the gully. So in this term, actually, it will increase the loading in the gully to the next one and then the subsequent one. So if you can see that for the gradient is actually the slope along the road, 2%, and then we may just limit the flooded width to be 0.75 meter. If you have larger gradient, then well we will limit the so-called flooded width to from 0.75 meter to 0.7 meter. And then if it is from 3%, 5%, we'll further limit it to 0.8 meter. And if the roll is 0.5%, and then we will limit the design flooded width to 0.66 meter. So actually you can see that it is related to the longitudinal gradient of the road for the gully spacing. Okay? Besides of the so-called surfaceability state consideration, we also have the so-called ultimate state consideration. As I mentioned, for the road section here, this is the road section here, then that's actually for the curb. This is for the curb. We call it this is the curb. And actually, if the water is too high, this is the flood width here. If the water is too high, then it will be flood on the footway. This is the footway. So we don't want actually the water or the flood will overtop the footway. And then so the so-called purpose of the ultimate state design is to prevent the occurrence of such overtopping. We don't want the flood flows to the footway. So actually for here, we will design our row actually to take over of intensity of 248 mm per hour. That means actually with a probability of 1 in 50 years. So for here, we will try to resist the rainfall of 1 in 50 years in order not to have overtopping of the flood to the walkway. At the same time, we will also mention, or we will also consider a factor of safety of 1.2. And then the flow height, actually, we call that H ultimate. It can actually be considered or calculated by using the equation 1. So you can see that this is the flooded wave, and then this is actually the height, or we call it the flow height. This is the flood. And therefore here actually you can calculate the flow height beside the curve. Actually it is the flood with an ultimate state. Flood with an ultimate state is actually this one. And then the cross flow of the row is actually this one. This is the floor cross flow of the row. That means the slope in the perpendicular direction of the row. And then times actually the flood width at the ultimate limit state. And then it becomes the flow height of the row. So this is actually the flow height that we need to consider, and then this one should not over the so-called curved height. Otherwise, actually, it will cause the flooding on the footway. So you can see that we will have 1.34 or 1.64 for hard shoulder on expressway, or 0.97, 1.13, 1.16 for normal road edge. Actually, this one is according to the rainfall zone as shown in the figure 1. So as you can see here, as I mentioned, you have different areas. You have the general application area. You have the so-called Taimusan area. You have the so-called the West Lantau Island area, and then you have the North District area. So as you can see, you may have 1.34 or 1.67 for the expressway, and then you have 0.97, 1.13 or 1.16 on the normal road. Actually, you have already been stayed here. So we will choose 1 in 70 or 1 in 50 years right here. So it depends on the location. If you are general application, and then if you are considering the normal road, then you will have 0.97 right here as the flooded width. And then for the expressway, you have 1.34, okay? Or if you are actually in the Taimusan area, then for the normal road, the maximum flooded width will be 1.16 meter, and then will be 1.67 meter right here, okay? Depends on your design. And then, well, you have the West Lantau area, you have 1.13, and then you have 1.67. And then here you have 0.97, and then 1.34 meter, okay? So it depends on the location of your road. Then you will choose the appropriate flooded width. And then once you have the flooded width, you just substitute here. This is your flooded width, and then you will multiply with the cross flow of the road, and then you will compare with this is the factor of safety of 1.2. And then you will calculate the so-called flow height of the highway, and then you will compare with the curb height. If it is less than the curb height, then actually it will not have the so-called the overflow or overtopping to the footway. And then normally, actually the curb height is 125 mm. This is the normal curb height of the road, okay? But if the cross floor is more than 7.8%, and then 10.7% on the normal road, that means if the cross floor can reach 7.8%, and then if it reaches 10.7%, then the flow height may exceed the so-called curb height. Then the drainage design should be revised. That means your current design is not okay. Then actually you need to change the so-called the cross floor or the curb height. Because the cross floor actually will affect the flow height, or actually if your curb height is not enough, you may increase the curb height. However, actually the cross floor or the curb height cannot be adjusted in most circumstances. And then, if it is the case, then actually you need to reduce the so-called spacing of the gully. That means your current spacing is not okay. Then you should consider so-called a reduction factor to reduce the so-called the gully spacing. For here, you can see that if the curb height is not enough, then well, you need to apply the so-called the reduction factor to your gully spacing. Then you will have H curb B, actually is the curb height, KERB is the curb, and then divided by 12, and then W ultimate is the ultimate flow width, and then divided by the 4 of the road. Then you will find the so-called reduction factor. This reduction factor should be applied to the spacing of the gully. So if you are reducing the spacing of the gully, of course you will reduce the flow height. Once you reduce the flow height, then actually you compare with the curb height again to see whether it will overtop or not. Okay? So actually, for the ultimate state consideration, as I mentioned, actually mentioned about overtopping. A curb height of 125 mm basically is a standard curb height right here. And basically, if you have a curb here, which is actually equal to 125 mm, well, basically, it will have 4 to contain any overtopping within a localized area. So your footway should have some 4 in this area. Then actually this one can also help to prevent the so-called overtopping on the localized area. But of course, for some area, you have some exceptional case with non-standard drop curve. And in that case, actually, you need to pay some additional consideration. Because actually, this is the footway. Basically, there will be some fall. When water is overtopping right here, then the fall will actually help to prevent the water from getting on the footway. But for some case, actually, there may be not the fall on the footway, then it may have the water to overtop of the curb. Then it will cause great problem. And then the cross floor actually is very important. you can see that the cross flow actually is the slope and then convert the water on both sides of the road. Actually, a slight variation in the cross flow will result in a significant effect in the gully spacing. Well, an increase in the cross flow, say from 2.5% to 3%, actually can increase the gully spacing by about 25%. That means if you have a larger cross flow, actually the water will go through the gully in a better way. So actually your gully spacing can increase by 25%. So if possible, actually we can apply the larger cross flow. Actually then you can reduce, the number of gully. That means you can increase the gully spacing. So on road with moderate or the steep gradients, in the guideline state that a suitable cross flow should be provided to ensure the surface water flows to the curbside channel rather than longitudinal along the length of the road. Now basically the standard cross flow is 2.5%. And then for some cases actually will increase to 3% at least. So the cross flow actually is a very convenient or very important way in order to reduce this number of gully or to increase the spacing of the gully. So as you can see here, if the slope or the longitudinal gradient is 1% or less, then in the guided notes we recommend that the minimum cross flow is 3%. And if the longitudinal gradient is 5% or more, we recommend that the minimum cross flow to be 3% again. Because actually, if the cross flow is larger, then actually can help to drain the water away, then you can increase the so-called the gully spacing. And then between 1% to 5%, it's recommended that the minimum cross flow is equal to 2.5%. So this is actually the requirement from the guided notes. And actually for the gully spacing, well, we have two equations to be considered. Because of the gradient, actually we'll have different criteria for design. So we will have a different equation if the gradient is greater than 0.5% or smaller than 0.5%. The gully spacing will be different. For the roads actually with a gradient greater than 0.5%, we have this equation. The unadjusted gully spacing is equal to 0.01 over n times A divided by W. N is actually the roughness coefficient. It depends on the status of the surface of the road. If it is, say, the friction cause or the concrete surface, then the N will be different. The roughness coefficient. And the A is actually the drained area. Actually, for this one, you can find that from the table. And then the drained width actually is the width that can have the drainage. Usually, it is the width of the road under consideration. So it is the so-called drained width. That means it's the width that water may drain from it. So basically, it is the width of the road, including the carriageway and then the footway. Because all the water on the drainage way and the footway can be collected by the gully, right? It is the drained area or drained width. So for different surface, actually you will have different coefficients, as you can see here. For concrete without flat channel, concrete with flat channel, and then for the bitumen-bearing course, for the precast block paving, for the stone mastic asphalt, then you can see that the surface coefficient is different, or we can call the roughness coefficient difference. You just choose a suitable one and then put in this equation, and then you can find for that. And then you can see that this is the chart for the drained area. For here, you can see that we will choose the cos 4 first. Say, for example, it is 4%. And then, well, for the longitudinal gradient, you can also choose the value, say it is 0.5%. So in this case, you can see that it's 4, and then you can choose 0.5, then you can go here, and then afterward you can go here. It is around 110 for the drain area in this case. So from this table, you can look up for the values of drained area. So you can substitute in this equation for A, and then W is actually the width of the road, which actually will have water being collected. And then remember, this is actually for the drain area for the gradient larger than or equal to 0.5%. And then this one is actually, we call that the calculation of the drained area. This one is for hard shoulder flows. So again, they are not the same because this is for general, this is for the hard shoulder flow only. Well, if it is an expressway, of course it will have hard shoulder, right? Then you use this graph instead. And then for here, for the Gauss spacing of flat or near flat and a gradient not greater than 0.5%, you have another equation. Now this is for 0.5% of the gradient or less than 0.5%, okay? For this one is greater than 0.5%, okay? So for the steep road, we have one equation for the Gauss spacing. And then for the flat road, we have another equation for the Gauss spacing, okay? LU is actually an adjusted Gauss spacing, LU. But before you also have one here, it is also LU. It is also an adjusted Gauss spacing. That means this is the first spacing that we determine, okay? It is depend on the drained area, and then depends on the drained width, okay? And then the coefficient of roughness. And the LU is actually, for this case, is equal to L naught, and then times 1 plus F, and then times R minus 1. L naught is actually the Gauss spacing for row of zero gradient. So you can see that, again, L naught is actually from a chart. You can get that from a chart here to find L naught. And the F is actually the adjustment factor for different drained width. So this one is actually another adjustment factor. It depends on the drain width. And finally, R is actually the multiplication factor for different cos 4 and gradient. So L naught, F, and the R all are actually from a chart, okay? So actually there are 3 charts that you can find L naught, you can find F, and then you can find R, okay? And then from here you can see that this is the chart for L naught for zero gradient of the road. So there's a force flow here, and then there's a drained width here. So it depends on the drained width and then the cross flow of the road. Then you can look at what is the spacing of the gully. But this is just for zero gradient of the road. And then this one is for normal road, or we can call it flat roads. And then this one is actually for the hard shoulder. If you need to find the hard shoulder flow, then you will use this table or use this chart. And afterward, as I mentioned, there is a table for the adjustment factor F. Then depends on the trigger wave, you will take a look what is the adjustment factor. And then finally, it's about for the R factor. Depends on the cross-fall and then depends on the gradient, longitudinal gradient. Then you will find the so-called the multiplication factor R. Say actually is 0.4%, 0.4% for the longitudinal gradient. And then the cross-fall is actually, say for example, 0.3%, then you can find the so-called the multiplication factor R equal to around 1.1. And then for the hard shoulder flow, again, if it's more than 0.5%, there's another graph here. And then you can see that if we plot all the things here under the Gauss spacing, you can see that for the longitudinal gradient, if it is increasing, well, then the Gauss spacing is also increasing. So you can see that if it increases from 1 to 2, from 2 to 3, from 3 to 4, actually you can see that the Gauss spacing are increasing. And then, well, for the same longitudinal gradient, say for actually this 4%, it actually have a larger cross-fall here. Actually, again, the Gauss spacing also increasing. Okay. So for both the longitudinal gradient and then the cross-fall, if they are increasing, then actually the Gauss spacing are also increasing. Okay. And then from here you can see that under this graph, actually the longitudinal gradient is 0.5%. Then actually you can see two values right here on the same values of the longitudinal gradient. Why is that? Because if you still remember, we have two equations to find out the Gauss spacing. One is smaller than 0.5%, one is larger than 0.5%. Okay? So for here, actually, we can use for both equations. So 0.5% is the criteria to change the equation. So for here, you can see that we have one equation to calculate for the Gauss spacing. For the case, the gradient is 0.5% or smaller than 0.5%. And then for the other case, actually, for here, you can also see that the Gauss spacing is larger than 0.5%. So you can see that 0.5% is actually a value to distinguish, to use both the equations. When it is larger than 0.5%, we have one equation, and when it is more than 0.5%, we have another equation. So for here, if you plot both of the equation on the graph, you can see that actually here we have two parts. This one is more than 0.5%, while on the right-hand side is larger than 0.5%. But the case where the gradient is exactly equal to 0.5, so you can see that there's a vertical line right here. So this is why you have such a graph here. And then for the design Gauss spacing, LU is the unadjusted Gauss spacing. For this one, we just consider the drain width and then drain area. But however, you can think that for the Gauss, actually there can be some debris or some rubbish. It will block your Gauss. If you block your Gauss, then actually, well, your drainage actually is not so effective. Okay. Then in that case, actually, you need to reduce the spacing of the Gauss. Because sometimes, actually, when there's some rubbish block your Gauss, then they are not effective. Of course, you need to put them closer in order to collect your rainfall. Do you agree? So, LU actually is the unadjusted spacing. Then we need to have 1 minus RF rating, and then 1 minus RF depth for consideration. But for the grating one, actually depends on the pattern of the gouting. And then for the depth one, it depends on the rubbish. So there are actually two types of the gouting in order to cover on the surface. And depends on the pattern. Actually, they have different effectiveness. So you can see that for here, actually, we have one type we call it a TA1450. And then for this type of the grading, then actually it's good for consideration. And then there's another type we call it the TA2325. And then you can see that the spacing, I mean the wall distance is not the same, and then the pattern is not the same. So actually they have different value. We call it RF grading reduction factor. For TA1450, so actually the reduction factor is equal to 0%. While for TA2325, actually it is equal to 15%. So actually, you should reduce by 50% if you use TA2325, while you do not need to reduce anything because the reduction factor is equal to 0 for TA1450. So there is no reduction factor for the type 1 gouting, while for the type 2, actually there is some 50% of the reduction. So that means for this one actually is less effective, while this one actually is more effective. Okay? 係佢呢度冇俾到嗰個 criteria。I think there's just one classmate mentioned about this one type which is actually in the using on the road. But actually the guideline didn't give, didn't mention about that new type of the grading. Okay? We need to wait for their guidelines or guidance because we don't know about the effectiveness of that kind of grading. Well, for conservative design, if there's no guideline yet, I will use 50% of the reduction factor at this stage if you ask me to design, okay? Because I will stand on the safe side actually. And then for the orientation of the grating, you have to use the follow one. That means follow the one in the guided nose. If you are putting in the wrong direction, you will reduce actually the effectiveness for around 20%. So you can see that the flow direction is in the one shown in the figure, and then you should arrange your pattern as shown in the guided nose. If you turn it like in the 90 degree, then actually the effectiveness will reduce for say the 20%. So you should follow what have been stated in the guided notes in order to get the so-called the state efficiency. Otherwise, it will be reduced for around 20%. So it depends on the grating. Actually, you will have the reduction of the spacing of the gouting. And then for the debris, as you can see, there may be some blockage of your gouting. Then, of course, if it is blocked, then the efficiency of the gouting will reduce. And then in that sense, actually, you need to put your gouting closer in order to have the same efficiency to drain your waterfall or rainfall. Do you agree? So for here, you also need to consider the debris coefficients. And then for the debris, actually depends on the area. Whether actually in the black spot, or whether you can in some amenity areas, or you will be in some landscape areas. Because in some black spot, actually like in the market, then actually there may be more rubbish. So it depends on the location. Actually, in the guidelines, they give different of the reduction factor for the blockage by the debris. So as you can see from this table, if it is for the expressway, then the longitudinal gradient is less than 0.5% or near the set point, then the reduction factor is equal to 15%. If the longitudinal gradient is 0.5% or more, like it is near the amenity area, like the landscape area, then actually it is just 10%. Like other areas, it is 5%. But it depends on the number of people or probability of people that will that will arrive those kind of area. If you have less people to be assessed those kind of area, then we can use a smaller reduction factor for debris. And then for the normal road, if the longitudinal gradient is less than 0.5%, then the reduction factor is at IS 20%. For the longitudinal gradient, 0.5 or more, then near the set points or the blockage black spot, like the Streetsbridge Market or Hawkers, then maybe it will increase to 20%. Near the amenity area, again, is 20%. For other section, we may limit it to 15%. It depends on the section of the road. Then you will have different, the so-called reduction factor. Okay. Okay. Before we further go on, and then we may take a break. You can take a rest, and then we will continue after around 5 to 10 minutes.